The importance of the grid on society is pretty profound. With both the pressures of decarbonization and the growth of electrification, all of that depends on a network, and that network already exists. It's the grid. You don't get another one. You're not going to rip it out and replace it. This is the one. You have to keep it secure and stable and available, as we always have. But the way it works and the way it's operated will change pretty dramatically. We will see a century's worth of change in the next decade. To keep the grid running, we've been relying on human beings, really intelligent people who get up every day and come in and make sure that when you flip the switch in your house, the light comes on and you don't even think about it. That they now have to deal with orders of magnitude more complexity, way more variety, way more velocity, way more volume. They simply can't do it all on their own anymore. We have to do it in a new way. You have to do it using digital technology. You have to do it using machine learning and automation and intelligence, because if you don't, you won't be able to keep up with the pace. GE continues to be a front runner in terms of applying digital technology to grid. Some of the things that we're doing that are profound and unique is one, as we look at how our distribution management system operates, the way it manages outages and at scale is something that is really unmatched. If you can imagine a place that it can be more disrupted by Mother Nature than Florida, I'd be willing to have that conversation with you. But the level of hurricanes that predictably try to disrupt that grid is profound. And the outage management system, the technology we deploy there, allows us to restore hundreds of thousands of customers in seconds. And so that's something that is why Florida Power and Light, even though they are so heavily impacted, is able to have such a high availability rate and actually fairly cheap energy, because they manage the cost of those recoveries because they can see them coming. They can predict them in ways that they couldn't predict before. They can recover in ways that they couldn't recover before, and we're proud that they're using our technology to do a lot of that. There are more intense storm events, more intense weather events, more fires, more ice, more everything. And the predictability of that is going down. So one of our missions was Storm Assist, and with the storm analytics that we also do is to try to predict when those things are going to occur, to use all of the intelligence and information available to us, and run that through models that help us predict the impact and localize that. What we can do is we can try and keep those outages to the most minimum, just the absolute smallest amount of downtime that we possibly can by, really accurate forecasting, good forward deployment, good real-time observation, good analytics on how to resolve that problem, and then smart deployment of crews and assets to go implement that solve. Advanced Distribution Management System, or ADMS, is then the software that's used to manage the entire low voltage distribution networks. That has to be more fault tolerant. It can't always manage around fault. Sometimes those things aren't predictable. You can have a car crash into a box on the side of the road and suddenly power goes out. So the distribution management system looks at basically, how do I sustain and maintain availability to the end consumer? How do I keep the light bulbs on in the home? How do I keep the air conditioning running? How do I keep the car charged? How do I keep the factory running? That's what the distribution management system cares about. DERMS is the Distributed Energy Resource Management System. What you're really talking about there is that the DER, the distributed energy resources, are going to be many. It can be solar, it can be windmills, it can be the electric vehicles. Those create not only a lot of things to worry about, but they are variable. And in the electric vehicles case, they even move around on the grid. We want to allow DER to be onboarded onto the network much, much quicker. So we look at how do we automate onboarding? How do we make kind of contribution subscription very easy, automated, and predictable? As we do that, we also need a whole library of what these things do. We actually manage the grids using digital twin thinking. So we try to actually understand the physics of what these things do. So we create a library and we work with a large ecosystem of partners to keep that library populated. So how much and how fast can a Tesla Model S consume? How much and how fast can a certain battery kind of push back onto the network if I needed to tap it? Those are things that we create kind of in an asset repository. The advanced energy management system allows the network operator to manage that supply to demand networking and to constantly maintain that frequency, that inertia and that load, and to do it in a way that keeps it redundant and available all the time. It uses a lot of automation. The AEMS is a very robust system. It has a lot of parts. So it's also the most mature, right? We've been managing at the transmission level because that network was fairly complex early on. It's where we've done a lot of our innovation. So we have alarming, we have the ability to look at fault and predict fault. We have look ahead capability. We have we keep all of that secure, so we wrap cybersecurity around that. One of the core critical parts of our entire software strategy is the network model itself. Every single thing that we do relies on a good understanding of what the network looks like. That model starts for us at the Geographic Information System, the GIS. We're the only energy software provider that actually has a native GIS. And the GIS is a critical part of the story. Basically, what it allows you to do is take this massive machine, this grid, and describe it in real physical space. Where exactly are the poles and the wires and the switches and the transformers and the generators? Where are they? How are they connected together? How are they working? How were they originally? What's the history of change for the network? That starts with the GIS. It's a key component of what we do. The great thing about GE and GE's customers is we've been partnering to solve these insurmountable problems for over 100 years on just the grid alone. GE helped turn the first group of lights on in Manhattan, building the first grid. And every one of the challenges that's come along was an insurmountable challenge at the time. And we invented things. We invented new things to solve that problem. We're at the precipice of an amazing transformation. And it's scary and there's risk, but it's something that we simply must do. And it's the kind of challenge that we rise to. Solving these problems, applying technology that we know deeply, understanding the physics of the grid because we make the grid, understanding, how a machine thinks because we design that intelligence. I think gives us an advantage that helps us in, quite frankly, our responsibility, being the people that helped invent this thing in the first place, to keep it moving forward.